All right, in today's example here, we're going to take a look at solving a system of equations here. This is 3 equations, 3 unknowns. Let's go ahead and do this. So right away, you can convert this to an augmented matrix, and you can combine the columns like 3, 4, 1, 10. You can copy it just as is, and that's fine. But when you're doing your row reductions, it's a lot easier to have 1 in the top left-hand corner. So I'm going to actually write this equation first, interchanging these two, and obviously interchanging these two. So interchange row 1 and row 3. I'm going to write it like this instead. Just makes it a lot easier when you're doing your row reductions. So if you ever have that chance, you should do it. And again, we want to make these values 0. So this will be row 2 minus twice row 1. This will be row 3 minus 3 times row 1. And again, reducing this, we get this for the first one. We're going to get 0 here, negative 3, 4, and 1. And doing the same operation, except for subtracting 3 times row 1, we get 0, 1, 4, and 7. All right, so the goal here again is to make this entry 0. I'm going to go ahead and take 3 times row 3. I'm going to add that to row 2. And doing so here, we get the following. I'm not touching the first and second row, so you can jot those out just as is. And this is going to give me 0, 0, and this ended up being 12. 12 plus 4 gives me 16, and this is going to be 21 plus 1 gives me 22 here. All right, and now I can go ahead and solve. All right, and you can see here now I've made this following expression upper triangular. Now it's just a matter of doing back substitution solving. So equation 3 is going to yield 12y, or I should say 16. You're going to get 16y equals 22. That implies that y is 22 over 16, which is also 11 over 8. Moving on to equation 2, again using back substitution, I get 3x. Plus 4y, but I know my y value is going to be 11 over 8, and I know that's equal to 1. So now if we go to solve this here, you end up getting negative 3x plus 11 halves is 1, in which case negative 3x is going to be here 1 minus 11 over 2. So negative 3x is going to be negative 9 over 2. And solving here, I end up getting that x is 3 halves for this value. So I know the value of y is 11 over 8. I know the value of x is 3 over 2. All right, so now solving for this here, you're going to get w plus x. My x value we just discovered was 3 over 2, minus my y value, which is 11 over 8, and that has to equal 1. So you have to go ahead and solve for this. I'm just going to multiply across by 8. I'm going to get 8w plus 12 minus 11 is 8, and in which case here we get 8w is 7, and w is 7 over 8. So putting this all together, the point of intersection, which is a unique solution, is going to be 7 over 8, 3 over 2, and 11 over 8 for this question here. So this is an example of 3 equations, 3 unknowns, which yields unique solution, and that point of intersection, like I said, is unique, and in this case, we have rational numbers. Thank you.